Hey guys, welcome back to another round of daily math instruction. Today we're going to be looking at Envision 10.9, which deals with volume. Okay, and we're going to look at a couple of examples with volume of rectangular prisms, but we're going to look at kind of some going a little bit farther, some higher level of application with volume. So I know you all know that volume, okay, typically is length multiplied by width multiplied by height. Okay, we're going to use that, but a little bit of a variation. Okay, so let's go ahead and begin with our first word problem. Before we begin, I just hope you guys are still enjoying yourself, having a great time, and getting an opportunity to spend time with your family, as well as hopefully get outside. I know it was really nice yesterday, so it's supposed to be the same today. So after you're done with math, take a chance and get outside and enjoy the nice weather. Anyway. So we have Cora has an aquarium with exotic fish. The tank is the size and shape of a trapezoidal prism. The distance from the front glass to the back is 2 feet. What is the volume of the aquarium tank? So we are just going to primarily look at just the tank part. Okay, so not the top or the base of it, just the tank. Okay. Well, notice that we're going to be looking at a trapezoidal prism. Okay, trapezoidal prism, when taking the tank and drawing that out, would look. You would have your bases as trapezoids, so your top base and your bottom base is trapezoid. And since it's a prism, you know that the faces are all going to be rectangles. They may not be equal rectangles, but they will be rectangles, and you will actually have 2 of them that should be congruent to each other. So looking at this, how would we begin to find the volume of it? Well, as I mentioned before, the formula that you guys are used to with volume is the length multiplied by the width multiplied by the height. Well, that works well for a cube or for a rectangular prism, but not so much when you start dealing with other prisms. Well, if you guys recall, with a rectangular prism, there's another way that you could manipulate this formula and get a different formula, but using a different formula that is more condensed, you could say. So instead, your formula for all prisms is to take the area of the base and multiply by the height. Sometimes you will see, since it's the area of the base, you'll see it as big B multiplied by H. But either one will work. So volume, in all this case, you're going to get the area of the base multiplied by the height. Well, let's take a look at this. So first we're going to need to figure out the area of the base, which in this case the base is a trapezoid. Okay. When we draw the trapezoid from here, we're going to have a base 1 of 3, and that comes from here, and base 2 is going to equal 6 feet, coming from here. The height, which is the distance from base 1 to base 2, when making a straight line from it that is perpendicular to the base, is 2 feet, and that comes from down here. Okay? So now we want to apply the formula for area of a trapezoid, which, if you recall, is this long, somewhat nasty formula where area equals half multiplied by the quantity of B1 plus B2, or base 1 plus base 2 in quantity, and then multiplied by the height. I'd like you guys right now to take a chance and evaluate what the area of the base is going to be. So hopefully you guys got, as you wrote this down, area equals 1/2. I'll do my best drawing this. Base 1 was 3 plus base 2, which was 6 feet, and then multiplied by 2. Following order of operations, 3 plus 6 will get you 9, so 1/2 multiplied by 9 multiplied by 2, and area, well, when you multiply all these together, gets you 9 feet squared. So we have the area of the base, or the area of the trapezoid in this case. So now we need to find the volume of the trapezoidal prism. Our formula is going to be volume equals base multiplied by height. Now recall, we do have the base now, which is 9 feet squared. I'd like you guys at this time to go ahead and see if you can figure out, using the area of the base and the height of the trapezoidal prism, see if you can figure out what the volume is going to be. So I'm certain that you guys were able to figure this out. You take 9, which is the area of the base, and that's a horrendous 9. I apologize for that. And you're going to take the height, which is 5 feet in this case. So you're going to multiply 9 by 5, and your volume is going to be 45 feet cubed. It's cubed because it is a three-dimensional shape. You're ending up going area is squared, and since you're multiplying the squared by one more foot, and that's going to get you 3 feet squared. So the volume of the aquarium tank is 45 feet cubed. I want you guys to go ahead and take a moment and see if you can figure out what the volume of this triangular prism is going to be. Now remember, the formula you are going to use is volume equals the area of the base, that's a massive B, multiplied by the height. That's big formula right there, guys. Okay, I want you to go ahead and take a moment, see if you can solve and evaluate the volume of the triangular prism below. Alright, so in order to do this, you're going to have to figure out what the area of the base is. Now your bases in this case are triangles. So area of a triangle, just as a refresher, is 1/2 base times height. Okay? So we're going to figure this out. We have 1/2 multiplied by the base, which in this case we'll say is 8 centimeters. We know it's the base because it's where the perpendicular angle is a 90-degree angle. Okay, where it is adjacent to our height. Alright, so we have 8, and then our height is going to be 6. We can figure out the area of the triangle by 1/2, or half multiplied by 8 multiplied by 6, which gets you 24 centimeters squared. We're going to substitute that back into our volume formula, which we get 24 multiplied now by the height of the triangular prism. The height is 14, so we'll multiply it. Whoa, that's a crazy 14. It kind of looks like one of my check marks there. Alright, so volume will then equal 336 centimeters cubed, or cubic centimeters. The volume of this triangular prism, 336 cubic centimeters. Let's keep on moving on. Now students are selling a souvenir basketball. Well, the basketball fit inside the gift box that has a regular hexagonal base. Now remember, regular hexagon means that all sides and angles are going to be congruent to each other, so that the lid fits on top. I want you guys to take a moment, read into this question, look at the model. What do you need in order to figure this out? Because now you're given the volume, but what are you going to need to figure out the basketball will fit in so that the lid will completely close? Take a moment and think about that. So from this problem, since we already know that the length of the box, okay, going from one end of the hexagon to the other end is 7 inches. Well, 7 inches is greater than the diameter of this basketball, which is 6 inches. So we know that it would actually fit into the box where it's not going to need to be forced in there. It would actually fit into it. But now we want to make sure that the lid fits on top. So in order to do that, we are going to need to figure out what the height of this hexagonal prism is going to be. And hopefully, if it's greater than 6 inches, then we should be good. All right. So in order to do that, we have to find the area, okay, of the base, which in this case is a hexagon. Recall that from finding surface area, to find the area of a hexagon, you're going to need to split the regular hexagon into 6 triangles, which has been done here in this model for you. Okay, since it's a regular hexagon, each side length is going to be 4 inches across all the way around. Now we would need to figure out the height. The height here is written for you, which is 3.5 inches. Well, where did we get 3.5 inches? Because this was 7 inches all the way across. Well, recall, in order to get the height of a triangle in a regular hexagon, you have to draw a straight line from the midpoint down to form a perpendicular angle with the base, or with one of the sides of the hexagon, in this case 4. And since it's the midpoint, the distance from midpoint to the side, it's going to be half of whatever would be all the way across, which is 7. Half of 7 is 3.5. So we would need to figure out the area of the hexagon. Well, since there's 6 triangles, we would multiply the area of one of the triangles by 6, which would be half, multiplied by the base 4, multiplied by the height 3.5. When you do this, you should get an area of, actually I'm going to let you guys take a moment and figure this out. Okay. You should figure out that you would get an area of 42 inches squared. Now we need to go ahead and figure out, now that we have the area of the base, we can use the volume to figure out what the height's going to be. So go ahead and write your formula. Volume equals big base multiplied by height. You know the volume in this case, which is 294 inches cubed. You know the area of the base, which is 42 inches squared. And you don't quite know the height yet, and that's what you need to figure out. You guys go ahead and take a moment and do that. Well, you should figure out that you need to set up a T-chart. Mine's like a wavy, groovy T-chart. And divide each side by 42. When you do that, 294 divided by 42 results in 7 equals h. So we now know that the height is 7 inches, which means, in this case, which means that the basketball would fit in there, because the height is greater than the diameter of the basketball. Let's keep on moving on here. This will be our last one for today. So Saquon has a shed for his athletic equipment. What is the total volume of the shed? Well, if you notice here, we have a composite figure, meaning we have 2 3-dimensional shapes or polyhedrons put together. All right. So in order to figure out this one out, you're going to have to find the volume of each composite, or each figure, and then combine the figures together. All right. I want you guys to go ahead and take a moment and see if you can figure out the volume of both of these figures, and then figure out what the total volume is going to be. So for this one, this is a cube since all sides are congruent to each other. So for this one, you can actually do volume equals s cubed, which means all sides are the same, and you can cube it 18 times 18 times 18, and that would get you what your volume is. So the volume of this cube is actually 5,832. Now continuing on, we would have to figure out what the volume of this triangular prism is going to be. Well, you would need to find the area of one of the triangles. In this case, it would be 10 multiplied by 18 multiplied by half, which gets you 90 feet squared, multiplied by the height, which in this case would also be 18, because you would move this, this side would be congruent to this side, which gets us the 18. And the volume get you the volume of 1,620 feet cubed. You can then go ahead and add the two volumes together to get 7,452 feet cubed for the entire volume of the two composite figure of the two prisms together. Okay? thank you guys for listening. Hope you guys have a tremendous rest